with you guys. So this is on your problem set 3B. This is the number 1 and 2 from the word problems, which is like the last half. So if there are extras, just put them on the left, stitch in the back, guys. Those papers I'm passing around, I'll get those momentarily. So I want you guys to tell me, how would you solve this doing dimensional analysis, which is that whole fractional problem-solving method? Yes?
Won't you set up an equation?
So you want to set up a proportion, is that what you want to do?
Yes.
I'm going to stray from that because I'm going to try to move us from proportion world to dimensional analysis world. So I'm going to actually stray away from that and show you how we did it last week. So I'm seeing the question is mass, right? So if the question is mass, in the end I want what unit? Grams, right? We all know mass is related to grams. And this is talking about mercury, so this little chart is on your problem set. And if you have it in front of you, it's a big chart, and I just snipped out a small portion of it. Mercury has a density of 13.6 grams per centimeter cubed. That's also described as grams per milliliter because 1 centimeter cubed is 1 milliliter. They are one and the same. They are interchangeable, and that's going to help you later on. And the question, there are a couple of other questions on your problem set. So I'm going to start with my 3.55 milliliters of mercury. Remembering that 1 milliliter is 1 centimeter cubed. I'm saying that out loud, but I actually can show that right here. I can show myself that 1 milliliter is equivalent to 1 centimeter cubed. Why would I want to cancel out milliliters and go to centimeters cubed? Because I want grams, but how am I going to get from milliliters to grams? Do you see a conversion from milliliters to grams over here? No. You see a grams to centimeters cubed or centimeters cubed to grams. You see that relationship, but you don't see milliliters there. So I'm just going to make it formal and select my milliliters, convert it to centimeters cubed. And then I can employ this density. Do I do it as it is, 13.6 grams per centimeter cubed, or 1 centimeter cubed per 13.6 grams? First one or second one? So do I want to put grams on top or grams on bottom here? Top, right, because I already see my milliliters cancel, wonderful. My centimeters cubed now needs to cancel, because remember my question up here is mass, which is grams. So I need to put it on top. You're right, grams needs to go on top, and then centimeter cubed needs to go on bottom. And the numbers that go with this are the density of mercury, which is 13.6, which is what this is in grams, and that's just per centimeter cubed or per 1 centimeter cubed if you would like to put a number there. So that whole process is dimensional analysis yet again. Milliliters cancel, centimeters cubed cancel, and 13.6 is going to be our number on top. So mathematically, what do I put in my calculator? So 3.55 times 13.6, and that is 48.28 grams. Then sig figs come back always, right, to nip us at the end. But now we need to decide how many sig figs we should include. What do you guys think? 3, because this front number up here, which is generally on these little small problems like this, we'll be looking at, but that says 3 sig figs. And there's also 3 sig figs here, so it's a win-win. 3 sig figs, round this for me. 48.3 grams. So I'm still making sure we're rounding out loud for me. The way you're doing it is 3 sig figs would be 4, 8, and 2. Remember the decimal does stay there, but this 8 does influence the 2 to be rounded up. That's why we did 48.3. Thumbs up. It's coming back. It's coming back. It's like 3 days ago. Okay. So density is just useful as a conversion factor, and it's going to be used down here as well. But I want you to see that this one is lead. We're starting off in liters. So what's our starting point? The very first thing I write. 1 second. Shout it out loud. Okay, so the thing given to you in the problem is the very first thing you write. So I'm doing the problem set with you, right? So make sure you're with me. I'm doing the one and 2 from the word problem set with you. All right, so liters are just not useful because I have over here, again, grams per centimeter cubed. I can't start with liters. What do you think I should convert that to that would then be useful? Maybe milliliters, right? Because liters can easily be converted to milliliters. And you're in your head going, okay, King named her dad by drink chocolate milk. What's that conversion?
1,000.
So 1,000, right? So now I need to think about where do I put it? So what definitely needs to go on bottom? Liter. What definitely needs to go on top? Milliliters. And then which one gets the 1?
The bottom.
Right, so 1 liter has 1,000 milliliters in it. So liters cancel, right? There we go. Now I'm in milliliters. Again, I don't see milliliters over here. I need to do the formal conversion of what? centimeters cubed, right? Same thing I did right here. 1 centimeter cubed is equal to 1 milliliter. I'm just formally putting it there versus saying I know it's equivalent. You're just showing it to me. So 1 milliliter goes on bottom because milliliters need to cancel. 1 centimeter cubed needs to go on top because we need to then be able to utilize the whole centimeters cubed conversion. And I only want that's because that's how I have density expressed in this little table for you guys for concept. So then milliliters cancel top and bottom. Wonderful. What's my last and final step? Multiply by. Hold on, I got one more step I need to put in here. Because I still haven't. I'm not to mass, right? Mass is grams. Go for it, Nick.
11.4 grams on top of it.
Okay, so he's saying look at lead's density, because this is concerned about lead. Lead has 11.4 grams per centimeter cubed, according to the density here. And you're right, 11.4 goes on top, because I need grams on top. And the 1 centimeter cubed that's underneath is just there so we can cancel out that unit. The purpose is to cancel all units except for which one? Grams, correct. So then mathematically, you put, what would you do? So 0.045 times 1,000 because you're going across the board. On top, everything numerator-wise is going to be multiplied. And all these things on the bottom are 1, so nobody cares. And then multiply by 11.4. And what do we get? 513 grams, right? And how many sig figs should we have in this problem? 2. Okay, so let's round 513 to 2 sig figs. Okay. I'll just start this baby up in third degree. Yeah. Thanks. Yes, I will. I'll treat it nice. Okay, so say that again for me. Round this. 510. Great. You guys are getting good at rounding. I will say first period brains are alive. Yay. Okay. All right, so I'm going to pause on concept 3B because I know I'm going to have questions from you guys later, but I want to kind of get us back started into our next activity, which is matter. Okay? So have your matter notes out for yourself. And you saw at the very end of the video some particulate diagrams. So if you didn't, then you'll be a little lost in this activity. You need to watch the video. So here's our 20-minute activity first. Maybe not quite 20 minutes, it depends on how much practice you need. But these are the little particulate matter parts that you saw in your video. And you can see that this first one up top has single circles that are all the way spread out. Well, if I'm a single circle, what am I? What type of matter? Say again? Elements. So these elements are singletons. What if I have one that's got a combined double thing, like 2 circles together? 5 compounds, 6 compounds are connected together through a chemical bond of some sort. And then think about states of matter. Okay, solid, liquid, and gas. Those are the 3 we talked about. There's plasma. But solid, liquid, and gas. How do you think a solid would look on a particulate matter card versus a gas? So tightly together would be what? Solid. So that's just they're really, really, really densely packed together versus ones that are very, very spread out would likely be what? A gas. So some of these particulate matter descriptions are things that you already know about the matter. It's just looking at it in a different way. So yeah. I won't give you on the plasma. They'll actually have like little. Sometimes I'll put like little tails on them to show like they're really fast because it's energized gas particles that are have electrical charge as well, and they can actually glow. Okay, so I can't really pick that on here right now. All right, so on this guy, this is kind of your flow of how you're going to work through this activity with these cards. The very first thing is describe pure substances and mixtures. It says look in your textbook, please look at your notes or your brain or a friend. And then after that, it says to separate them into pure substances and mixtures and so forth. And it says A through R. So like these little cards have numbers or letters on them. It says A through R. It's A through infinity. However many cards you have is what you're going to separate into the different categories. And then you'll just follow through. Okay? So whatever you're doing, write it on your own paper. You guys will work with a partner. Claim them with your eyes now. Claim them. Look at them. Claim them. Okay, don't look at like 5 people. Look at one person. Okay? All right, so I'm going to put a timer on the board, but I'm going to ask you guys to come back here with a yellow sheet and a card set. And you move around the room and do what you guys do, okay? Let's go. We all write like 6. You guys can grab a card set for your partner set. Here, actually, Darcy, grab these.
Right on the
One of the ladies at the time. Do you have a partner? Yeah. You guys can grab a card set there. Okay. Elements combined with compounds. Right there. Two elements in place, combined.
one paper each.
Every single person is writing. So yes, one paper per person. So two people per two notebook pieces of newspaper per group. Everybody's writing something down because I want you guys to work together, but you're also doing your own work too. So someone to collaborate with. You got me?
It's an element. But basic. No, you have to write a description of describe. You don't like. I don't think we use the criteria.
Pure substances and composition.